welcome back. In this lesson, we're going to get started working with raster data by taking a tour of the Spatial Analyst toolbox. We'll give you a sense for each of the tool sets in the toolbox and demonstrate a couple tools very briefly for you. So first, the Spatial Analyst toolbox is just one of the toolboxes in ARC Toolbox, but it's the one that primarily deals with raster data in particular. It also deals with creating rasters from vector sources or analysis workflows that use vector data as inputs to generate rasters. A big reason we're taking a look at the Spatial Analyst toolbox is that your final project in the capstone of the specialization will be really centered around geoprocessing. So we want to make sure that you have a good sense for all the geoprocessing tools available to you so that you can start to design algorithms both for the capstone but for your own work as well. One important thing before we get started is that in order to use the Spatial Analyst toolbox, we have to enable the extension. So we go to Customize, Extensions, and I select the Spatial Analyst toolbox here and click the checkbox next to it, and then I click Close, and that checks out the Spatial Analyst license. If I didn't do that, the Spatial Analyst tools would give me a warning that they're unlicensed and I wouldn't be able to run them. You might have noticed that there were also some other extensions in there for 3D Analyst, so you need to do the same thing for those tools as well. So let's take a look inside the toolbox. First, we have the conditional tool set, which has a few tools in it that allow you to subset your rasters, as well as combining rasters when certain criteria are met. So the con tool is conditional. You can open it up. It lets you evaluate a raster for sort of truth or false using an expression, and then have one raster be the result if true and another if it's false. We'll demonstrate that in a later time, but for now know that you have some tools for kind of comparing information in rasters. Next up, we have the density tool set, which allows you to create density rasters based on feature data. So the values in the raster will be density information. So it can either use feature locations or locations and a field with a value to decide on that density. The next tool set is the distance tool set, and the one I'll show you right now is the Euclidean distance tool. So in the last class you used the buffer tool at one point to create polygons where things were within a certain distance of a feature. The Euclidean distance tool will create a raster that provides a continuous stream of information, a continuous field for an entire area of the distance from certain features. This is useful because the buffer tool allows you to create features that say, okay, what's within a certain distance, and the Euclidean distance tool allows you to basically say, okay, how far away is something else? So let's take a look at the Euclidean distance tool. And first, let's just select these features right in this area here, and we'll use those as the input for the Euclidean distance. And I'll leave the output or the default in my default geodatabase there, and we'll set the max distance as 8,000 meters. Say I'm going to set the cell size to 100 meters, and we won't get an output direction raster. We don't need that right now. I'll click OK. It's going to run, and it gives me a raster with distances away from the features that I had selected here. So right now they're binned, but it's actually continuous information here. So if we go to properties and set the symbology, I can, instead of classified, I can go to stretched, and we can look at this in a similar symbology, but continuous information here. So it's just a fine gradient of information at the cell size that I specified for the rasters. And then we have these null values in here because I selected a maximum distance of 8,000 meters. This tool and the distance toolset are great because then if we had some other features, we could figure out how far away they are from the features in this feature class. And when you start combining this tool in different ways with other tools, you have some powerful tools available to you to determine different distance metrics. Okay, so next up is the extraction tool set. And the extraction tool set lets you pull information out of rasters based upon given areas of interest. So you can use a mask, which could be any polygons or circles, or extract by specific attributes, all sorts of ways to get a new raster back based upon criteria you specify. Next up is the generalization tool set. And it's a basic set of analysis tools that let you perform operations that help prepare your data for other tools. For example, the region group tool finds contiguous areas of a raster and assigns them a new value that's a sort of region ID. It can be helpful in segmenting rasters for further analysis. We'll probably demonstrate that in an upcoming class, but for now, know that the generalization tool helps you transform your rasters into new rasters based upon specific criteria. The groundwater and hydrology toolsets do basically what they say they do. They deal with groundwater modeling and surface water flow. So we can find where water is flowing, which direction it's going to flow in, and then how much water has flown into a given area, and different watershed information here. But we can also model groundwater in the groundwater toolset. The interpolation toolset is very powerful, but it's also one of those with great power comes great responsibility things. Don't use them until you understand them. We'll talk about interpolation later on. But interpolation is the process of inferring unknown values through modeling based on known values. So it's commonly used to turn point observations into continuous rasters. Maybe we had points in these locations where the polygons were instead, and we needed to use an attribute there on the points to infer the values as a continuous raster in between the points. So maybe you have a network of air quality monitoring stations and you want to get a complete picture for a region. This allows you to do that. But again, you're likely to come up with invalid results if you're not careful. Make sure to do your research and know what you're doing first. The local and neighborhood tool sets allow you, they help you by focusing on individual values in each raster rather than kind of the complete picture, and how those individual values relate either to other rasters or to the cells surrounding the current raster. They're kind of useful building blocks for other tools. Map algebra is great, and we're going to demo that in a later lecture in this course, in this lesson. And it provides tools for writing your own basic raster functions. The raster calculator is a very powerful, very flexible tool, and it's an important one to know. The math toolset does kind of what it looks like. You can do various mathematical functions, and it's important for running mathematical operations across an entire raster. It's great for modeling and for basic operations where you know an algorithm you want to build or have specific inputs that need to have traditional math run on them. Multivariate provides tools for working with and classifying multiband rasters like imagery. And then overlay provides methods for combining rasters based on criteria you specify, the importance of each one, things like that. Similar sort of tools for overlay exist for feature classes as well. There's an overlay tool set in the analysis toolbox. Raster creation is great because it allows you to make new constant or random rasters with cell sizes and extents you specify. You can also create rasters with a normally distributed set of values. These are sometimes useful as starting points for other analyses. I also sometimes use these as a shortcut to create a continuous polygon boundary based upon the extent of a raster. You can create a constant raster and set your environments so that you get a continuous raster with the same value and then convert that to features. The reclass tool set is great. It allows you to take a raster and assign a range of values in the raster into a new value in a new raster. So you can assign classifications or make new classifications to the data in the raster. It's really useful in many workflows. It's like the binning that we saw earlier in the table of contents, except instead of assigning a color based upon a group of values, we assign a new value in an output raster, which we can use to feed into other tools. So maybe in that air quality example I said before, we've received model results and we want to score areas based on air quality hazard for the day. So we want to take those results and sort of interpret them for the public. So the public maybe doesn't know what the model results mean, but we want to reclassify those results into index we have, a scoring system. So we can reclassify to assign the highest tier of the model a score of 5, a lower set of values a score of 4, or even a lower range of values a score of 3, and so on. Segmentation and classification is used when you're working with tools to train the computer to automatically identify features in your multiband rasters. We'll likely cover this a little more in the fourth course. And then solar radiation can provide detailed information on how much sunlight an area is receiving based on a digital elevation model. So if you need to know solar information either for solar panels or for something that requires daylight information, that's your tool set. The surface tool set's pretty important in my line of work because lots of what we do with water and terrain is based on processing available in the surface tool set. So we have all the stuff we'd use when we're working with a digital elevation model. We can find the slope of each cell in a raster, the direction that cells are facing, which is aspect. You can create contours and hill shades to use for your terrain maps. You can fill the volume of locations or on your DEM with cut fill, and you can deal with questions of visibility with the viewshed tools. It's a really useful set of tools here. I'm going to quickly demo the slope tool. It's really simple, but given a digital elevation model, we can find the slope either in degree or in percent rise. So I'll leave it as the default geodatabase version again, and then we can set a scaling factor as the z factor here too. I'll leave it as 1, which means that it's not going to scale the values at all. I'll click OK. Then switch back to where we'll see the digital elevation model again while it's being generated. So here we get a slope raster back that matches what we're seeing in our digital elevation model. So there's this big flat area down low here, and so we could see that, but then also these kind of high areas on the edges of them, we have a lot higher of slope. So these are probably the tops of the bluffs here. They're kind of flatter and evening out, and then these are the sides that are steep. So slope tool is really great, and you can use that to feed into further calculations. And finally, at the bottom of the Spatial Analyst toolbox, we have the zonal toolset, which is my favorite. It's so great. I'll show you an example later in this lesson. And it extracts statistics from the raster into fields on your vector data, which sounds kind of mundane, but think of it this way. If there was a raster to vector spatial join, this would be it. You're extracting information from your raster and turning it into fields on a vector data set of zones of interest, where zones are any polygons you care about. Really cool set of tools in the zonal toolbox. Okay, that's it for this lecture. I just wanted to give you a sense for the tools available for working with rasters in the Spatial Analyst toolbox. You'll need to use some of these inevitably. You may not need to be familiar with all of them, but I wanted you to know they all exist. Go take a look, play around with the data yourself, get a sense for how it all works. In the next lesson, we'll begin working with raster data in earnest. See you there.